In the final years of the 20th century, the United States solidified its dominance in aerial combat. With groundbreaking aircraft like the Lockheed Martin F-22 Raptor and the Northrop Grumman B-2 Spirit stealth bomber, it looked like no other country could possibly catch up. These machines weren't just planes. They were seen as flying miracles of modern warfare. Back then, China was still working with outdated Soviet-inspired aircraft. But in the decades since, everything has changed. Now the skies over China feature increasingly familiar silhouettes, jets that closely resemble American fighters. And according to multiple intelligence sources, those similarities aren't just visual. Are we looking at a new global contender, or are these designs simply borrowed tech without the brain behind them? Let's begin with the most ambitious aviation effort in the United States today, the Next Generation Air Dominance Program, or NGD. Boeing recently secured a major contract under this initiative, surpassing even Lockheed and Northrop, to deliver a new sixth-generation fighter for the U.S. Air Force. Designated the F-47, this advanced aircraft has reportedly been flying in secret for nearly 5 years, aligning with a 2020 statement from the Air Force that NGAD had already entered test flights. But the F-47 isn't just another fighter jet. It's designed to be the centerpiece of a future aerial combat ecosystem, acting as the central brain of a network of systems, including autonomous drones and next-generation sensors. It's stealthier, smarter, and faster than anything before it. Cost-wise, it's set to be cheaper than the F-22, which means the U.S. Air Force plans to acquire up to 300 of them, replacing its current fleet of around 180 Raptors. The design is tailless for better radar evasion and features next-gen canards to enhance agility. It'll boast adaptive propulsion engines generating up to 40,000 pounds of thrust, pushing the aircraft beyond Mach 2. Its range, over 1,500 miles. The F-47 will come in both piloted and unmanned versions, with mission-specific configurations. And its weapons package? Hypersonic missiles, swarming drones, and soon, laser weaponry. This is no longer science fiction. Lockheed Martin is already working to integrate directed energy weapons into U.S. fighters. Meanwhile, China's answer to America's sixth-gen efforts is wrapped in secrecy. But glimpses have emerged. In late December, video footage surfaced showing 2 new aircraft flying over Chengdu in Sichuan province. One believed to be the heavy J-36, the other a lighter model suspected to be the J-50. Both designs resemble a tailless flying wing, like the U.S. concept. One of the aircraft bore the number 36, fueling speculation about its designation. Analysts believe Chengdu is behind the J-36, while Shenyang is responsible for the J-50. But whether they belong to a single development program or 2 parallel ones remains unclear. Sources claim the J-36 might be powered by China's WS-15 engine or an undisclosed next-gen system. Its range is expected to be about 1,200 miles, a bit short of the American F-47. However, the key difference may lie in systems integration. While the U.S. builds its aircraft to operate as part of a massive, interconnected command and control web, China's doctrine still prioritizes local tactical integration rather than global reach. So even though the J-36 might match U.S. fighters in speed or stealth, it lacks the deep digital backbone that makes American systems so effective. Let's not forget the 5th-generation F-35 Lightning II, a plane that changed the game. Over 1,000 units had been built by 2022. Known for its versatility and rapid response capability, the F-35 is now in service across a wide network of U.S. allies. What makes it so powerful? Its stealth features, advanced avionics, and unparalleled sensor fusion offer a tactical awareness that no other aircraft currently matches. But developing it wasn't easy. Its mission system software alone contained over 8.6 million lines of code in the 3F block, and the more advanced Block 4 update required major improvements to cooling systems and hardware architecture. In the future, the F-35 will integrate more closely with NGAD platforms and drone teammates. Lockheed is working on giving the F-35 up to 80% of the capabilities of the future F-47, but at only half the cost. Meanwhile, China has its own multi-role stealth fighter, the J-35, also referred to as the J-31 or FC-31. This jet aims to rival the F-35 in both air-to-air and ground strike capabilities. Its radar system and helmet display are inspired by American and British tech. In September 2023, the Chinese military revealed the first flight of the land-based J-35A, an offshoot of the carrier-based version, with modified wings and landing gear. Despite its progress, the J-35's tech still lags. It lacks the full sensor integration seen in the F-35 and remains dependent on more conventional radar systems. And there's more controversy. In 2013, U.S. defense officials alleged that Chinese cyber attacks on the F-35 program allowed them to accelerate their own development. The similarities between the F-35 and J-35 are hard to miss. Comparable size, layout, and overall function. But when it comes to actual combat readiness, the J-35 is still in the testing phase, while the F-35 has proven itself in missions over Iraq, Syria, and Afghanistan. Speaking of experience, the F-22 Raptor, America's first fifth-generation stealth fighter, remains unmatched. Its export was banned by law to protect sensitive tech. Every inch of the Raptor was sculpted for stealth. Seamless surfaces, angled edges, and super maneuverable engines. The twin Pratt & Whitney engines produce over 35,000 pounds of thrust each, enabling the F-22 to cruise at supersonic speeds without afterburners. So is China catching up? Absolutely. But are they there yet? Not quite. While Beijing pushes forward with ambitious stealth programs, the United States continues to evolve its aerial arsenal with advanced networks, autonomous systems, and a level of battlefield intelligence China hasn't yet matched. The race for air dominance is far from over, and what happens next might just redefine the future of warfare in the sky. If you found this deep dive into the future of aerial combat fascinating, be sure to like, subscribe, and hit that bell icon so you don't miss our next episode on the evolving balance of global military power. Thanks for watching. Imagine traveling from New York to London in just over 3 hours, cutting transcontinental travel time in half. It's a dream that's closer to becoming a reality than ever before. But can we overcome the challenges of supersonic travel to make it practical, affordable, and safe? Let's dive into the cutting-edge technology shaping the future of aviation. For decades, the idea of ultra-fast aircraft capable of crossing continents in mere hours has captured the imagination of engineers and travelers alike. While aviation giants like Boeing and Lockheed Martin are advancing hypersonic missile technology, a groundbreaking company named Boom Supersonic is tackling a different challenge, bringing back supersonic passenger flights. With their XB-1 demonstrator and ambitious Overture airliner in development, the dream of supersonic travel might soon become a reality. But is this vision practical, and are we truly ready for such rapid advancements? Let's find out. The concept of hypersonic and supersonic flight has a long and turbulent history. Aerospace historian Richard P. Hallion once compared faith in hypersonics to belief in the second coming. Everyone knows it's possible, but no one is sure when it will happen. For over 60 years, hypersonic technology has seen cycles of interest and stagnation. Early challenges with rocket engines, re-entry protection, and air-breathing engine designs deterred progress. The Cold War-era military focused on traditional fighters and bombers, sidelining hypersonics due to their steep technological barriers. Today, however, hypersonics and supersonics are resurging, fueled by advancements in materials, engine technology, and the geopolitical arms race. Hypersonic weapons are viewed as game changers by the Pentagon, while companies like Boom Supersonic are looking beyond military applications to revolutionize commercial air travel. Boom Supersonic's XB-1, affectionately nicknamed Baby Boom, is a scaled prototype paving the way for the Overture, a supersonic passenger jet designed to carry 65 to 80 passengers at Mach 1.7. That's twice the speed of today's fastest commercial airliners. The XB-1's innovative design includes advanced composite materials, titanium, and stainless steel capable of withstanding extreme temperatures. Its sleek, swept-wing structure minimizes drag and maximizes efficiency, while its 3 General Electric J85-15 engines provide the power needed to break the sound barrier. But the real game changer lies in Overture's promise to solve the long-standing issue of sonic booms. By flying supersonic routes primarily over oceans and subsonic over land, Boom's team aims to eliminate disruptive noise pollution. The Overture also leverages sustainable aviation fuel, SAF, striving for net zero carbon emissions, a nod to the increasing demand for eco-friendly travel. Despite setbacks, including pandemic-related delays, Boom has made remarkable progress. In 2023, the XB-1 completed its ground testing in subsonic flights, demonstrating its stability and efficiency. The company now aims for its first supersonic test flights in 2024 and plans to have the Overture ready for commercial service by 2029. The path to revolutionizing air travel with supersonic speeds is not without its hurdles, and one of the most significant challenges is cost. The Overture, Boom Technologies' ambitious supersonic airliner, comes with an estimated price tag of $200 to $250 million per jet. This high production cost will inevitably influence ticket pricing, especially in the early stages of commercial operations. The parallels to the iconic Concorde, which charged passengers around $10,000 for a transatlantic ticket in the 1990s, roughly $20,000 when adjusted for inflation, are hard to ignore. These steep prices made the Concorde a luxury experience, accessible only to an elite few, and the fear is that Overture might face the same initial exclusivity. However, Boom Technology has a bold vision that extends far beyond catering to the wealthy. The company's ultimate goal is to make supersonic travel accessible to the masses. Blake Scholl, Boom's CEO, dreams of a future where traveling across the globe at supersonic speeds isn't a privilege reserved for the few, but a reality for many. The dream includes ticket prices dropping to as low as $100 for a 4-hour global journey, a proposition that sounds like science fiction today. Achieving this goal will require breakthroughs in not only technology, but also manufacturing efficiency, operational scalability, and partnerships with airlines willing to invest in a new era of air travel. The race for supersonic travel is heating up, and Boom Supersonic is at the forefront of this groundbreaking movement. With their innovative designs and ambitious goals, they might just redefine the way we travel. But will supersonic flights ever become as commonplace as modern subsonic airliners? Or will the challenges of cost, noise, and infrastructure keep this technology out of reach for most travelers? Let us know your thoughts in the comments below. If you enjoyed this journey into the future of aviation, don't forget to like this video, subscribe to the channel, and hit the notification bell for more insights into cutting-edge technology. Thanks for watching, and we'll see you in the next video.